All right, good morning, everybody. Oh, thank you, Stephanie. I'm very happy to be here this morning to welcome you all to the 4th Annual Symposium. And I'm Jennifer Smith. I'm a program manager at the USDA California Climate Hub. Our program has been involved with this project, and I've been really enjoying serving as your MC for the past couple of annual symposiums you all have had. Our program at the Climate Hub works in that space that bridges science to action on the ground really often, and everything I hear here every year is very inspiring in that space. So, without further ado, I'm going to introduce Dr. Isaya Kisekka to start us off with a bit of a look back at the project so far.
Thank you, Jennifer, and thank you all for coming to our 4th Annual Symposium. I'll start by giving a very brief overview of the project. Our project is funded by USDA NIFA, the National Institute of Food and Agriculture, and our focus is sustaining groundwater-dependent irrigated agriculture systems in the southwestern United States and a changing climate. I'm the PI for the project, but I work with colleagues across the Southwest and different universities involved, as I'll show later in the presentation. Our vision is to secure groundwater for food, environment, and people. And our mission is to alleviate groundwater overdraft. We don't want wells going dry. We want to protect groundwater quality in major aquifer systems, advance socioeconomic resilience of groundwater-dependent agriculture through agroecological and technological innovations. These NIFA SAS projects, or Sustainable Agriculture Projects, are the largest projects that the USDA grants. They are usually $10 million, and they are supposed to be integrated, which means they need to have research, education, and extension. And as part of this project, we were also awarded a Center of Excellence. So we have a Center of Excellence on agricultural water that is housed at the University of California, Davis. We are organized in 5 objectives. The first objective focuses on sustainable agriculture systems. The second objective focuses on water and hydrogeological techniques. We have colleagues working on socioeconomics of groundwater governance and groundwater use issues. Then an objective on education, workforce development, and capacity building, and then extension programming. In the interest of time, I'll not go through all the topics that we are working on, but you can see that we organized in 3 pillars in terms of research: groundwater, ranging from quantity to quality to policy issues, to a wide range of agriculture systems issues, as well as socioeconomic issues. These are the universities involved across the Southwest: University of Arizona, Stanford University, also federal agencies, USDA ARS, Fresno State University, New Mexico State University, UCANR, University of California, Berkeley, and Kansas State University as the external evaluator. We also have several partners we are working with, including the Almond Board of California, CDFA, the New Mexico Department of Food and Agriculture, Elephant Butte Irrigation District in New Mexico, DWR, Madera County, and so many other stakeholders. This is our study region. The major aquifers we are focusing on are the Central Valley Aquifer System in Central Arizona Pinal Active Management Area, and the Lower Rio Grande in New Mexico. The red dots on the map show our field sites where we work with growers to evaluate different practices like groundwater recharge or soil health practice or different management practices across the region. This is a QR code for the program. If you don't have a paper printed out for the program, you could scan this QR code to get the program for today. I put here one statement that sort of summarizes the major impact of this project. This project has delivered technical foundation for field-ready practices and policy frameworks needed for resilient, equitable groundwater management, advancing smart recharge, protecting groundwater quality, sustaining agricultural productivity, and strengthening literacy and workforce capacity, and accelerating real-world adoption of water-efficient groundwater sustaining practice. This is a mouthful, but it captures all the different aspects that more than 24 researchers are working on this project. Again, I would like to appreciate our funding agency, USD and NIFA, our advisory board. Stephanie, you've done a fantastic job, as well as all our other advisory board members, our grower collaborators, students, postdocs, and other researchers involved in the project. I would like to show a short video. I'll get it to work here. No.
We are living in a new world where we know that water supplies are limited and uncertain.
We have overdrafted groundwater resources for many decades in some places, and it takes many decades then for nature to make up for that, even if we were to significantly reduce groundwater pumping today.
Our aquifers have been quite depleted over the last 100 years. We've pumped out over 160 cubic kilometers of water out of the ground. That is about 1.3 times the volume of water we have in Lake Tahoe. These wells have run dry, causing the ground to sink. Roads are cracking, some canals have seen a reversal in flow direction, and we do see times of excess of water. You have regions with flooding. There's lots of water available at very short times, so we're trying to capture some of that water and put it intentionally into the ground so we could use it for later.
Farmers were struggling with chronic shortages in water supply, driven by frequent drought cycles, limitations of pumping due to new regulations, as well as increasing costs of inputs. What doesn't work anymore is farming as if water supply was abundant.
It's difficult to manage what you can't see. The fact that groundwater in this way is a common pool resource with easy accessibility, it's actually much harder to control that resource. Water quality has degraded in many places to where we have to treat that water at enormous costs to make it actually usable. There are different types of contaminants, they move differently through groundwater, but all combined to have contributed to significant degradation in the quality of our groundwater resources. And we may end up having to do treatment even to use it as irrigation water in the agricultural landscape.
Whenever you introduce water into an aquifer, it actually needs to meet certain water quality standards. So you can't take surface water that might contain sediment, biological pathogens like E. coli or bacteria, and then pump it into an aquifer and then contaminate a whole aquifer. So this is why applying it at the land surface is actually preferred, because the subsurface soil acts as a filtration system and will take out all of these constituents, and then the water is relatively clean when it reaches groundwater.
In this project, we're working on both the water quality concerns and the groundwater supply concerns. All this is data. It's data about soils, it's data about crops, it's data about management system, it's data about climate, it's data about the subsurface that we feed into these models that then allow these models to make these predictions.
The first step to managing groundwater comes from education. Education is so very important with groundwater. It's something that you wouldn't understand just from looking at it, but you need to understand it because it has such a profound impact on our lives.
cooperative extension collectively is help people understand what the water situation is, what are the challenges, what are the trade-offs, and how we might come together and arrive at and implement solutions. It's really a two-way street of engagement, and it really is all about to connect with the water users, connect with the researchers, and connect most importantly with community.
At the core of what happens when groundwater is managed correctly is that the community is engaged, the farmer is engaged in how to implement practices that have been shown to improve on supplies or on groundwater quality. The community is engaged in knowing what improvements to expect on their wells, how soon to expect them. The regulator is engaged in structuring regulations in ways that incentivize the farmer to do certain things, that disincentivize land users from doing things that are harmful to either water quality or water supply. And there is communication about what is being done and how does that relate to what we're expecting to happen based on the models that we've used to make predictions about future of groundwater supplies and groundwater quality.
The work that's happening in this grant is about science and learning, economics and law. It has the potential to be very, very impactful. So when you fund education, you are funding the uplifting of the people that are going to be working on the things that matter to you.
Cover cropping, holistic water planning, efficient irrigation technologies. There's no single silver bullet, but farmers are innovators. When given the right tools and the right policy environment, they can adapt and be very efficient in how they use resources.
We are building tools for agriculture, for regulators, for environmental groups to better assess which practices will impact groundwater quality or groundwater supply.
I'm very hopeful and optimistic that all these tools used together will make our water-limited systems more resilient to climate extremes and other uncertainties in the future.